So thank you very much, Marcelino. Can everybody hear me? Mic is working? So first of all, it's good to be here. It's good to be back after 2-3 years not meeting in person. It's important to have the exchange, and we have to encourage more of our colleagues to join us next years and on every occasion we have, because there's a lot of things we have to talk to. And what I want to do today is give you a little bit also a look back, what have we achieved in MEMS, and give a look forward, what is coming. And I think this is the nice thing about MEMS. There are a lot of things happened already the last year, and that's also something we can really now tell everybody. Imagine for a moment that an extraterrestrial alien would come to the Earth. It would be quite obvious to them that a lot of these human-made things are the artifacts which they can observe here in our new world. A lot of the electronic circuits which are here, in innumerable applications on all around us, that's something we created. And part of this story is also MEMS. So the aliens would see tiny little MEMS, sensors, actors, moving, resonating, and then leading to their operations and giving us a good input in our world. And that's what we, the community, has achieved the last 25 to 30 years. And that's already quite a lot of things we have to bring to the table. So if we are coming here, if you are here this morning, I think you probably had already your first experience with MEMS in your real life. Think about the smartphones where you have the sensors in. It starts with portrait landscape. Everybody likely used it this morning. That's a MEMS sensor, typically an accelerometer which you use. And I also assume all of you are here. They also used navigation based on the smartphone, which is of course also based on MEMS sensors. It's gyroscopes and accelerometers which we have in and give these experiences. Otherwise you would have had to use still old maps, paper maps, to navigate to this location. So you do not think about this is MEMS what we have, but think about this is what we enable, what we bring to the world. And I think we can be proud of this. So tell it to the people. That's something which easily we can be brought to everybody and tell it to the students. Why? We need the students. They have to really study electrical engineering. They have to study physics. They have to study all these sciences which we need to fill up the gap we heard this morning. So it's 80,000 people are missing, now 40,000 added here in the US. It's the same in Europe. I think we have a good story, and we have to bring it to the world, and we have to bring it to the young kids, encourage them to study this. And that also makes me proud, seeing these applications coming up in such a lot of devices which are very beneficial to human beings. I'm very proud especially that our applications are also able to improve our lives and even save lives. And that really makes me very proud. And I will give you a few examples of the history and the future of MEMS. Let's start with airbags, with acceleration sensors in automotive application. Actually, I think that was likely the first high-volume application we have seen, airbags, acceleration sensors in airbag systems, which triggered the airbags. And in that sense, and I think that's a number for the US, which we read here, the 50,000, up to 2017, more than 50,000 lives have been saved by these tiny little accelerometer leading to the ignition of an airbag. And that's great. Saving life with MEMS, that's what we can do and where we can really bring benefit to the world. Now, of course, famous examples is ESC, electronic stability control. Till 25 years ago, SUVs have been the most unstable vehicles, at least at high speed, at autobahns or highways. And this was, of course, or is because of their high center of gravity, which these vehicles have. This changed. SUVs, minivans, crossovers are now riding safe at high speeds on autobahns and highways. So what changed? For sure not the center of mass or the center of gravity of these cars. It was the ESC, electronic stability control, an innovation or an invention which was brought to the market by Bosch, which in the end measures with a gyroscope and with an accelerometer the motion of the car It really connects it to the intention of the driver, where he wants to steer, and then acts on the brakes by the ABS system to control the car. And of course, there are two fatal issues which are addressed. One is really road departures, which can be limited or eliminated, and the other is, of course, rollover. And that, in the end, also saves a lot of lives. You see it here, that even in the US, it's 4,000 persons in a year which are saved their lives here in the US only. And especially if you look at rollover, which is probably the more efficient way of really avoiding these disasters in the ESC application, you can even have a reduction of 75% of these fatalities for SUVs and around 72% for cars. And I think that's amazing. That's really saving lives, which is triggered or made available by small MEMS sensors such as gyroscopes and accelerometers. Another example is tire pressure sensors. So tire pressure monitoring is a very important application. If you want to be safe, tire maintenance is important, and one step is to control the tire pressure by, most of the cases, by small pressure sensors. In doing so, you have constant data which show you if you are in a safe mode, if you have enough tire pressure in, and you can be warned in case this is not the case. And so think about the blowouts, which really lead also to fatal accidents on highways. If you are crossing at high speed and you have a blowout of your car, of the tires, that's not a good thing to have. And this can be avoided, and that's also saving a significant amount of lives. Also, these are numbers for the United States, around 660 per year, which we have. And even more important, in running your car at the right tire pressure, you can also save a lot of gasoline. And estimated for the US, running your car at the right tire pressure, it's around $500 million of gas saved in the cars, and that's also CO2 reduction, so that's also impressive. That's not saving lives, but that's reducing the pollution. I think that's also something we should be proud of. These are the tiny small sensors which we are talking about, and they are already reality. But it's going beyond. It's not only in cars. That was the first phase, of course, of the high volume industrialization of MEMS sensors. It's going also in power tools. Think about a drill or a circular saw, which is cutting into a material, and maybe it's locking into these materials, and you will figure out a kickback. If this happens, it can really hurt you significantly. You may even fall from a height in doing so, and that's also on risk to get harmed on this way. And this can also be solved with a gyroscope mounted into the motor drive of these power tool devices, just detecting that there is this locking coming up, reducing the speed of the motor and avoiding these fatal accidents in the power tools. So that's a good example how the sensor made it, originally developed from automotive into new application, and that's only one example which we see right now. And if we stay with these power tools, it's not only this, let's say, kickback function which is solved by MEMS sensors, it's also a safety relevant features, it's fall detection. Think about an angle grinder who is getting out of control, falling to the floor and not switched off. That can really generate a hazard and significant damage. So putting an accelerometer in a power tool which detects a fall and switches off the motor is really a safety feature. And that's already reality. That's in a lot of these devices implemented, and nobody maybe knows about it or even talks about it. So please also talk to your environment to show them what we as an industry can bring already now to the market. A new application, and that's I think still really up to date, is saving forests, saving lives. So environmental sensors, which are put in waste and spread out sensor networks, for example, in a forest, can help to detect very early upcoming wildfires. And in doing so, this may help us to also save significant amount of CO2 consumptions. So 20% of the CO2 consumptions on the world is caused by wildfires. And that's also saving our world, our planet. That's one topic. The other topic, of course, it's also a personal threat. If you see these climate changes we have, more strong winds, droughts, which we have, these wildfires are getting more and more severe. I don't think I have to tell you what I'm talking about. It may even really have an impact on your property or even risk your life. And that's also hopefully avoiding these incidents and making the world also a little bit more clean with having these sensors in the applications. I think there are two companies here at this event who will tell you more about the impact and the implementation of these systems in the forests. And so it's also a nice application which is just on the way to be implemented. Let's see what we can achieve and how we can really take the benefit out of these sensors. The uses, gas sensors, for example, VOC sensors, metal oxide-based sensors or similar sensors, which sense the changes in the gases in the forest and then can support the alerting process of this system. It's the same kind of sensor, also a gas sensor, which helps you in your home and giving you advice on ventilating your home, for example. So giving you a better air, less pollutions, more focus in your thoughts, what you are doing, and of course also helping to prevent airborne diseases such as we have it with COVID. That's also gas sensing, which can help you to have better air in your homes. And it's not only, let's say, more well-being in that case. It's not really life risking what we are talking about, but it may help even also to save energy on your side. So if you ventilate the right way, not too often, you may not have to heat up your apartment that often. That can save also heating energy, and that's a real big issue in Europe and Germany, as you are aware. So that may help the people to save a little bit costs and energy. Let's go to consumer devices. So if you see an emergency call, maybe a first responder coming up, what does this have to do with your smartphone, for example? But think about pressure sensors in smartphones. What are they for? Yes, it's already well spread that they help you to have a more accurate calorie counting. If you are walking steps, that's completely different from walking on flat floors. So you get more precise calorie counting. That's already done. That's not what I want to focus here. I think what I want to focus here, pressure sensors in smartphones are used for detecting floors. So if you have an emergency call, and the first responder is looking for you, it's a big difference if you're on the 30th floor on the skyscraper in the first. So finding people with acute symptoms very fast is really life-saving. Minutes or even seconds may count, and that's why it's a big benefit having pressure sensors in smartphones or in mobile devices to help the first responders to find you faster and hopefully bringing you back into a good shape very soon. And if you want to go down this path a little more in technology, currently the pressure sensors are able to detect a height difference of a few centimeters. So let's say an inch, and that's quite impressive. It's well enough to detect between different floors what we have right now. But also the technology has made significant progress the last years. The devices are much smaller, less power hungry, what we have more accurate despite being very small, and that's also an achievement of our industry. That's what we have achieved. It's not only enabling new application, I think it is and was hard work on technology, on design, on the products, on the application to make this happen, and that's something we as an industry can be proud of, definitively. The same pressure sensor, maybe a gyroscopes, is also very beneficial in helping elderly people or also detecting, for example, faults, accidental faults of elderly people, or also sport injuries very fast. And in detecting these, let's say, faults from elderly people, you are also able to make an alarm. Your family can be alarmed automatically, or maybe a dispatch service can be alarmed. And it's the same as with these, let's say, first responder activities. Also here, time may count. It will help the people to have a safer life and maybe also be with an independent lifestyle more longer in our world together with us. So let's celebrate a little bit. I think it's also worth to say, yes, that's what we achieved. And before moving forward, we can ask ourselves, so how did we do this? How did we achieve this the last 25 to 30 years? Of course, there was first the big automotive industry, which had a need, which pulled the technology and industrialized it, paid for it also. We brought it to a high volume application and volume application and a high revenue market. So somebody had to pay, and it was repaid by automotive. And of course, the demand of a sensor performance and the processes was huge. And one of the most significant processes or important processes making this happen was the Bosch process at that time. That's probably used now from everybody and made these scalable MEMS also happen. So after this automotive scaling, industrializing of MEMS in the 90s and early 2000s, we had the consumer electronics, which was pushing significantly. And the benefit of the consumer electronic was it made a sensor smaller, less power hungry, and even still very, very performant. And this is what we can benefit also in looking forward for our future applications if we want to move forward. That's what we achieved so far. And the question now is, how is it moving forward? So currently, we have a huge platform of technology, of products, which can be leveraged in upcoming use cases. And there are a lot of use cases to come. So this miniaturization and low power consumption, which was driven by consumer electronics, enables new use cases, for example, in your home, in the industry, in smart cities, and that's what we have to go for. This is what we can address also with our future application, and there's a huge potential to drive these applications. So, for example, if we have, let me look it up, I want to look for a number. So if we have human-centric societies which leverage the technologies, I think they will be also prone to use these new technologies and make it available. We have seen this in the previous talk when we had these applications with maybe artificial intelligence, but it starts already earlier. If we can adopt the sensors where we have the technology from consumer electronics, also to the needs of people, of industry, etc., we have to make them easy adaptable to the people. And that means we need, for example, software, we need intelligence, we need artificial intelligence in really adapting the sensors to the people. We want to really make benefit to the people. We do not want to really, the people behave according to the request of a sensor electronics. So we want to really have, similar as it is in Industry 4.0, leverage this technology and bring benefit to the people, make them more independent in their lives, support their life also, for example, with respect to tracking nutrition. Is there enough water they drink, or did they take their medicines? So that can really help people to stay more independent in their life. And that's, I think, new, what we are talking about. It's now more about knowing what the people need, knowing the applications, and bringing the benefit with software which can be adapted to the specific application, also to the people, and then adapt new use cases. So it's a scaling of the application of MEMS which we do. Maybe the volumes are not that high as we talk for consumer electronics, but there is a huge benefit and a huge amount of use cases which we can address going down this path and adapt with software, artificial intelligence, the MEMS sensors to these new use cases. Another example is mobility. So the urbanization brings a huge challenge to the mobility. Of course, we talk about electrification, we talk about autonomous driving, everybody is aware of this, but we also talk about smart mobility. So smart mobility in maybe smart cities. So you want to use this, let's say, navigation sensing, which we already talked about in the smartphones earlier, now also for smart mobility in cities where you have urban canyons, where you have undergrounds. So you want to really have also a tracking or a navigation in these kind of environments. And think about, this is an environment where you don't have a GPS signal available. So if you want to really navigate in these kind of environments without GPS, you have to have very accurate inertial sensors, magnetic sensors to make this happen. And this is what we can endure and do. And that, of course, talking about smart cities, helps also fleet management of all kind of devices to know where the vehicles are and provide the services also to the environment. This is something which also requires software, not only hardware. It's improving the signal quality of the sensors and make a stable navigation without GPS possible. That's what our sensors are able to do. Another application which is coming up is environmental sensing. Yes, I think having good air pollution is a big topic. And if we want to sense, yes, we have to measure. I think there's still a lot of room for detecting signals, detecting electromagnetic pollution, of course, air pollution, maybe radioactive pollution, whatever you want to know. And if you want to do so, I think we have to go also for application. It's typically gas sensing what we are talking about. But I think it's also particle sensor, which is coming up. So there is also PM2.5, which will be very beneficial to the people and giving the hint, okay, maybe open your window to ventilate or don't open it, or maybe better wear a mask or don't wear a mask. If you are interested in a PM2.5 sensor, there is a white paper on our homepage. You can look it up. What is the benefit of a PM2.5 sensor? So far, I think we already have a lot of sensors available out of smartphone applications which can be used in smaller volume applications. They can be taken to the new applications. Most important is we have to get in contact with these new applications. I think this is a challenge. If you look back, automotive or smartphones, we had a lot of volumes behind. We only had 3 handfuls of customers which drove the market, and this is changing. These applications, smart cities, health, industry, now have a lot of customers and have a lot of use cases. And to address these use cases, we have to get in contact with them. So how can we do this? I think we have to go out networking. This is a good opportunity. But we also have to use our networks, for example, venture capitals. We have tech events, we have tech scouting, which we need. We need a lot of research to go in, just to also identify these new cases, find new trends, and then also adapt to the needs for these applications. We also have to understand what these applications are needing for. And if we can leverage software, that's already a big benefit for us to go into these new markets and find the new applications happen. So it's getting more fragmented. There is a huge potential out. We have to go for it. It's not only hardware, it's also software. And let's address it with all the abilities of connecting through different events to look for these new applications. If we want to do so, of course, we have to adapt to the needs of these kind of customers. It's also a huge interaction with partners and customers, and you think about how can a smaller company adapt to sensors. So the big companies in automotive and consumer electronics, maybe also in the larger industries, they have armies of system engineers and system developers. If you go for smaller companies, they do not have it. So we have to bring microprocessors, we have to bring application software, we have to bring programmable, easy programmable sensors to these kind of customers to enable their applications. And one good example which we have shown, we have used an Arena board from Bosch-Sensortec, it's called Nikla, and we have been able to make a new use case to ensure the safety of workers in Singapore in putting a sensor system into a helmet to just detect if there's an accident on their side or if they are falling right now. And this device has a microcontroller, a programmable microcontroller software. You can really adapt to the use case. And within 3 months, it was possible to bring it to the market. And this is what we have to go for. It's not only bringing the hardware to the market. I think we have to understand our customers and maybe even the customers of our customers if we want to scale MEMS. Let me summarize up. I think I want to show you that we have achieved a lot. Saving lives, improving the quality of life, started with automotive, then went to the smartphones. But my message is also there is a bright future. Sensors and actors are needed everywhere in the world. If we want to address it, we also have to develop ourselves. Yes, it's still new hardware, but beyond it's also software, it's microcontrollers, also going directly into the packages. It's application softwares, it's artificial intelligence, which we have to address, and then I think we can scale also our applications. It's also connecting to our customers and the customers to customers, because it will be more important to understand use cases also from a sensor vendor side in future to make the sensors and sensor solutions fitting to the needed applications, and in doing so, I think we have a bright future. We can go out in the world and look for new applications for Invented for Life. Thank you very much.
Thank you, Stefan. Doesn't that feel good, right? That we're saving lives and having fun in the process. We have time for one question for Stefan.
The E911 example you gave, that's dependent upon other systems because atmospheric pressure changes depending on your height, the weather conditions. So how do we engage and make sure that that type of backbone information is available to our sensors?
In the end, it's the same with the air pollution, where you have to put a system in place. It's also with this E911 application. There are our redundant systems and the service behind to make this happen. Of course, you can connect these systems then to the outer world, to the weather conditions, and calibrate the sensors. There are different ways on doing this, but that's one of these examples. It's implementing of a system which is based on a MEMS sensor and which needs maybe our inputs or data calculation to make it happen. Yeah, and that will be more the usual case. Also, an airbag sensor, an accelerometer, is not only deciding if the airbag is coming up. So that's also a lot of electronics behind and justification, verification to make this happen.